Okay, here we go with the next installment of electrons. We're first going to look at our practice VECs that we worked on from the last particular slides that we saw, the last video that we saw. So we know what the shorthand notation was this for. So if we copied that down and underlined the VEC, the part that we would have underlined would be 4S2 4P4. That's what you should have underlined after you did your shorthand notation. This one should be 4S1. This one would be 4S2. This one would be 5S2 5P5. And then finally 6S2 6P3. All right, so next is the table that you should have filled out and all of the correct VECs if you got it right. So this is what your table should be in terms of VEC. So you can see that all the ones in group 2 have VECs with S1. All the ones in group 3, I'm sorry, this should be, my bad, this should be group 1 and that should be group 2. So sorry about that. So all of these have S1s, all of these have S2s, all of these have S2P1s, you can see that all the way down, S2P2s, S2P3s, S2P4s, S2P5s, and S2P6s all the way down. So the only thing that changes is the energy level. So we can see there's something here that's common. They all have the same number of valence electrons. So this one has 1 valence electron. This one has 2. 3, 4. Remember, 2 plus 1 is 3. 2 plus 2 is 4. This one is 5 because 2 plus 3 is 5. This one is 6 because 2 plus 4 is 6. 7 because 2 plus 5 is 7. And finally, 8 because 2 plus 6, and it's not writing for some reason, so I don't know if I've gone over the space there. So, next, we see the periodic table. Well, there's something here that's really interesting about this, and you can see it right here. So, I have the valence numbers listed above here. So we have 1, 2, 3, 4, 5, 6, 7, and 8 as valence numbers there. So really interesting factor is that you can count the tall columns on the periodic table and get the valence number. So again, 1, 2, 3, 4, 5, 6, 7, 8. So if you just count the tall columns, you will know the valence number without having to do the VEC. But the valence numbers are produced from the valence electron configuration, and that's where we get that. So next, valence electrons and Lewis dot diagrams. Now this is actually pretty simple. So rules of the game. Number of valence electrons in a representative element is determined by counting the tall columns on the periodic table. We just saw that. If we count the tall columns on the periodic table, we now know the valence electrons for those particular elements. So the way we do this, X represents the symbol of one of the elements. X is the symbol of an element. Then we use dots, and we go around in this sort of imaginary square box that's around the symbol for a total of 8 electrons eventually if you need them. So if we look at boron, boron is a 2s2 2p1, so it needs 3 valence electrons. So notice I have 3 dots. Now I would have written this one over here, but it has 3 dots. This one's nitrogen has a 2s2 2p3 for 5 total dots. So you see 1, 2, 3, 4, 5 dots there. So you're going to practice some of these: arsenic, astatine, potassium, silicon, thallium, oxygen, lithium, and krypton. So practice by writing the dot structures of these, as well as completing the dot structures on the lab that you were given yesterday.